Managing moisture within a polyvinyl chloride or PVC enclosure, particularly when it houses sensitive equipment like wiring for temperature monitoring or fused electrical components, requires a multifaceted approach. Several techniques can be implemented to mitigate moisture buildup and protect the integrity of the contents. These include improving ventilation, utilizing desiccant materials, selecting moisture-resistant construction materials, applying insulation, and employing waterproof sealants. Improving ventilation is crucial for reducing humidity levels inside the enclosure. This can be achieved by installing a ventilation fan to actively circulate air, or by incorporating passive vents that allow for natural airflow. It is important to ensure that the enclosure has both an air inlet and an air outlet to promote effective cross-ventilation. Without proper airflow, moisture can become trapped, leading to condensation and potential damage. Desiccant packets can be strategically placed inside the enclosure to absorb excess moisture from the air. These packets contain materials like silica gel or calcium chloride, which have a high affinity for water. It's crucial to replace these packets regularly, as they become saturated and lose their effectiveness over time. The frequency of replacement will depend on the ambient humidity levels and the size of the enclosure. Opting for polyvinyl chloride or PVC pipes or sheets that are coated with a moisture-resistant material can significantly enhance the enclosure's ability to withstand moisture. Chlorinated polyethylene or CPE and polyvinyl chloride or PVC with an acrylic coating are two examples of such materials. These coatings create a barrier that prevents water from penetrating the polyvinyl chloride or PVC and reaching the sensitive components inside. Insulation plays a vital role in preventing temperature fluctuations within the enclosure. By insulating the exterior, you can minimize condensation, which occurs when warm, moist air comes into contact with a cold surface. Foam insulation and rigid plastic sheeting are effective options for insulating polyvinyl chloride or PVC enclosures. These materials help to maintain a stable temperature inside the enclosure, reducing the likelihood of condensation formation. Sealing all joints and openings with a waterproof sealant is essential for preventing moisture from entering the enclosure. Silicone and latex-based sealants are commonly used for this purpose. It is important to apply the sealant thoroughly, ensuring that there are no gaps or cracks through which moisture can penetrate. Regular inspection and reapplication of sealant may be necessary to maintain a watertight seal. When dealing with an enclosed box within the polyvinyl chloride or PVC enclosure, additional measures can be taken to further protect the contents from moisture. These include wrapping wiring connections, elevating the box, using a breathable material, and monitoring humidity levels. Covering exposed wiring connections with waterproof tape or dielectric grease can prevent moisture damage. Waterproof tape provides a physical barrier against moisture, while dielectric grease creates a water-resistant seal that also helps to prevent corrosion. Placing the box on raised supports can reduce moisture exposure from the ground. This elevates the box away from any standing water or damp surfaces, minimizing the risk of moisture wicking into the box. Consider lining the box with a breathable fabric, such as felt or canvas, to absorb any remaining moisture. These materials allow for air circulation while also providing absorbent surface to capture any condensation that may form. Regularly checking the humidity levels inside the enclosure using a hygrometer can help you to identify potential moisture problems early on. If humidity levels are consistently high, it may be necessary to implement additional moisture control measures. Regular maintenance is essential for ensuring the long-term effectiveness of moisture control efforts. This includes inspecting and cleaning the enclosure to remove any moisture or condensation buildup, replacing desiccant packets as needed, and checking insulation for any damage or gaps. By following these techniques, you can effectively manage moisture levels within a polyvinyl chloride or PVC enclosure and protect sensitive equipment from damage. Remember that the specific measures required will depend on the environment in which the enclosure is located and the sensitivity of the equipment it houses. A proactive approach to moisture control will help to ensure the reliable operation of electrical and electronic systems. Consider that the 20 amp fuse holders inside the enclosure are to protect against overcurrent events. Fuses are designed to interrupt the flow of electricity when the current exceeds a predetermined level, preventing damage to equipment and reducing the risk of fire. The fuse holders themselves should be properly rated for the voltage and current they are intended to carry. When wiring Christmas lights, especially for a 28-day temperature wiring test, it is important to use appropriately rated wiring and connections. The National Electrical Code, or NEC, provides guidelines for selecting the correct wire size and insulation type for various applications. It is also important to ensure that all connections are properly made and protected from moisture. Poorly made connections can create heat and increase the risk of fire. Regular inspection of the wiring and connections is recommended to identify any potential problems early on. When working with electrical equipment, always follow safe work practices and wear appropriate personal protective equipment, or PPE. This includes items such as safety glasses, gloves, and insulated tools. If you are not familiar with electrical work, it is best to consult with a qualified electrician. Temperature wiring refers to the process of monitoring temperature changes over a period of time. This is often done using thermocouples or resistance temperature detectors, or RTDs, which are sensors that generate an electrical signal proportional to temperature. The electrical signal can be measured and recorded using a data logger or other monitoring equipment. In the context of Christmas lights, temperature wiring may be used to assess the performance of the lights under different temperature conditions. This can help to identify any potential problems, such as overheating or premature failure. When working with electrical circuits, it is important to understand the concepts of voltage, current, and resistance. Voltage is the electrical potential difference between 2 points. It is measured in volts. Current is the flow of electrical charge. It is measured in amps. Resistance is the opposition to the flow of electrical charge. It is measured in ohms. These three quantities are related by Ohm's law, which states that voltage equals current times resistance, or volts equals amps times ohms. Understanding Ohm's law is essential for troubleshooting electrical circuits and ensuring that they are operating safely. When selecting fuses for the fuse holders, it is important to choose fuses with the correct amp rating and voltage rating. The amp rating should be slightly higher than the normal operating current of the circuit, but low enough to protect the equipment from overcurrent damage. The voltage rating should be equal to or greater than the voltage of the circuit. Using fuses with the wrong rating can be dangerous and could lead to equipment damage or fire. The National Electrical Code, or NEC, provides detailed information on selecting fuses and other overcurrent protection devices. It is important to consult the NEC when designing or modifying electrical circuits. When working with polyvinyl chloride, or PVC, enclosures, it is important to select materials that are compatible with the environment in which the enclosure will be used. Polyvinyl chloride, or PVC, is a durable and weather-resistant material, but it can be affected by certain chemicals and extreme temperatures. If the enclosure will be exposed to harsh chemicals or extreme temperatures, it may be necessary to use a different material such as stainless steel or fiberglass. It is also important to ensure that the enclosure is properly grounded to prevent electrical shock. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and energizing the circuit. The National Electrical Code, or NEC, specifies the requirements for grounding electrical equipment. When installing electrical equipment, it is important to follow all applicable codes and regulations. The National Electrical Code, or NEC, is a widely adopted standard for electrical installations in the United States. Local codes and regulations may also apply. It is important to consult with a qualified electrician or electrical inspector to ensure that all installations comply with the applicable requirements. When working with electrical circuits, it is important to use proper wiring techniques. This includes using the correct wire size, making secure connections, and protecting the wiring from damage. The National Electrical Code, or NEC, provides detailed information on wiring techniques. It is also important to use appropriate tools and equipment for electrical work. This includes items such as wire strippers, crimpers, and multimeters. Using the wrong tools or equipment can be dangerous and could lead to injury or equipment damage. Regular inspection and maintenance of electrical equipment is essential for ensuring its safe and reliable operation. This includes checking for loose connections, damaged wiring, and signs of corrosion. Any problems that are identified should be corrected promptly. It is also important to keep electrical equipment clean and free from dust and debris. Dust and debris can accumulate and cause overheating or other problems. When working with electrical equipment, it is important to be aware of the potential hazards. These hazards include electric shock, arc flash, and fire. Electric shock can occur where a person comes into contact with a live electrical conductor. Arc flash is a sudden release of electrical energy that can cause serious burns and other injuries. Fire can occur when electrical equipment overheats or malfunctions. To minimize the risk of these hazards, it is important to follow safe work practices and wear appropriate personal protective equipment, or PPE. When working with electrical equipment, it is important to stay focused and avoid distractions. Even a momentary lapse in attention can lead to a serious accident. It is also important to avoid working when you are tired or under the influence of drugs or alcohol. These factors can impair your judgment and increase the risk of accidents. If you are not sure how to perform a task safely, it is best to consult with a qualified electrician or other expert. It is always better to be safe than sorry when working with electricity. Remember that electricity is a powerful force and should be treated with respect. By following safe work practices and taking precautions, you can minimize the risk of accidents and injuries. When working with temperature wiring, it is important to select sensors that are appropriate for the temperature range and accuracy required. Thermocouples are a common type of temperature sensor that are relatively inexpensive and can be used over a wide temperature range. Resistance temperature detectors, or RTDs, are more accurate than thermocouples, but they are also more expensive and have a narrower temperature range. Integrated circuit temperature sensors are also available, which combine the sensor and signal conditioning circuitry into a single package. When selecting a temperature sensor, it is important to consider the accuracy, range, response time, and stability of the sensor. The accuracy of the sensor is the degree to which it measures the true temperature. The range of the sensor is the temperature range over which it can operate. The response time of the sensor is the time it takes to respond to a change in temperature. The stability of the sensor is its ability to maintain its accuracy over time. When using a temperature sensor, it is important to calibrate it properly. Calibration is the process of comparing the sensor's output to a known standard and adjusting the sensor to match the standard. Calibration is necessary to ensure that the sensor is providing accurate readings. The frequency of calibration will depend on the type of sensor and the application. When wiring temperature sensors, it is important to use appropriate wiring techniques. This includes using the correct wire size, making secure connections, and protecting the wiring from damage. The wiring should also be shielded to minimize interference from electrical noise. When installing temperature sensors in a polyvinyl chloride, or PVC, enclosure, it is important to protect them from moisture and other environmental factors. This can be done by using a waterproof enclosure or by coating the sensors with a moisture-resistant material. It is also important to ensure that the sensors are properly grounded to prevent electrical noise. When using a data logger to record temperature data, it is important to select a data logger that is appropriate for the application. The data logger should have enough channels to accommodate all of the temperature sensors being used. It should also have a sufficient sampling rate to capture the temperature changes accurately. The data logger should also be able to store the data in a format that can be easily analyzed. When analyzing temperature data, it is important to consider the accuracy and resolution of the data. The accuracy of the data is the degree to which it represents the true temperature. The resolution of the data is the smallest temperature change that can be detected. It is also important to consider the noise level in the data. Noise is random variations in the data that can obscure the true temperature signal. Noise can be reduced by using shielded wiring, filtering the data, or averaging multiple readings. When using temperature data to make decisions, it is important to consider the uncertainty in the data. Uncertainty is the range of values within which the true temperature is likely to lie. Uncertainty can be estimated by considering the accuracy of the temperature sensors, the resolution of the data logger, and the noise level in the data. It is also important to consider the potential for systematic errors, such as calibration errors or sensor drift. By understanding the uncertainty in the data, you can make more informed decisions. When working with electrical equipment, it is always important to prioritize safety. Electricity is a powerful force that can cause serious injury or death. By following safe work practices and taking precautions, you can minimize the risk of accidents and injuries. Always remember to turn off the power before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment, or PPE. If you are not sure how to perform a task safely, consult with a qualified electrician.